I love calculators. That's right. We're going to learn how to calculate density, and the calculators make it so easy. I just punch in some numbers and I hit that enter key and it does everything for me. I don't need to do anything by hand. We're going to use technology to its advantage. So, how do we calculate the density value of a substance? Well, if you've taken a little bit of science or some chemistry, they're giving you the equation. We already talked about the equation. That equation says D equals M over V. And this is how we calculate a density value. Take the mass, divide it by the volume, calculate D. Great. Most people can do that. But in example problems, sometimes they get a little tricky and they'll say, ooh, this object has a density value of this, and this is the mass of that object. How much space would it take up? So we got to solve for V in that manner. Or they'll say, here's an example problem. Here is the density of the object, and this is how much space that object takes up. How much would it weigh? So we need to calculate M for that reason. So a little bit of algebra is going to come in. And for my advice, this is the equation that you need to memorize if you don't already know it. D equals M over V. We plug the numbers into this equation and we solve the equation using a little bit of algebra. Not very difficult. It's just basic kind of algebra intro 101, and we'll work through some of those example problems just in case you might be a little rusty on that stuff. For those of you that are algebra inclined, then you'll see a god-awful thing that looks like this. They'll say, ooh, here's a little triangle, and this little triangle will tell you what to do. If you need to calculate density, then you need to take mass, and then you need to divide it by volume, and that's how you calculate the other one. And then they'll go and be like, oh, well, you know, this little triangle will work for everything. So let's say that you've got your mass. This is a value that we know. And let's say that we've got a density value. So we take the mass and we divide by density, and that will allow us to calculate volume. Ooh, there's a second equation that I got to memorize. And now let's say, oh, well, let's say that we've got volume and we've got density, and we just multiply those two things together in order to get mass, if that's what the equation. Oh, there's a third equation. Keep giving them to me, one after another after another. I hate these triangles. And the reason is because it makes it more complicated than what it needs to be. Memorize one equation and learn how to do the algebra. Learn how to solve the equations. That's what you need. So the only thing that I really ever use is the density. One equation is easier to memorize than this triangle, trying to figure out where things go and what gets divided and what gets multiplied and everything else. That's what's wrong with today's math world. So one equation, fill in the numbers, and solve for a little bit of algebra. So if you've noticed, in this equation, they have used this P in order to talk about density. That is not a P. That is something called rho. That is a Greek letter, R-H-O, right? So that is going to be the representation of density. And you're going to see rho show up when we talk about specific gravity a little bit later on. And that is what that variable will often stand for in the scientific world. So we've already talked about how to manually do some of these measurements, right? So in the last video, we talked about taking a liquid. And we said, listen, what I can do here is that I can measure things on a balance, and I can measure volumes of things, and that allows me to calculate density values for solids or for liquids or for whatever thing that we're using. In this example, in this image, what you're seeing is how they calculate density for typically a solid. And it's not a perfect world, so solids do not always have perfect little streamlined dimensions. They are irregularly shaped. All right, so this is the process of what we would do to calculate density here. I would take the unknown object, and here is my chunk I've always been told, you're going to get a lump of coal for Christmas. Okay, well, this is my lump of coal that I got from Santa Claus. Thank you, Santa. I deserved it. All right, so here's my lump of coal. And that little lump of coal is going to be slammed onto a balance. And that balance is going to say, oh, well, here is your grams. You got quite a bit chunk of coal here because I've been a really, really bad boy. So 482.63 grams of solid gets measured out onto a balance. Ding, ding. What I've just got is my mass value. So I've got one part of the 3. And now I'm going to measure the amount of space that takes up. I cannot take a ruler. And I cannot measure the length and the width and the height of this thing. It is not symmetrical. It is not a regularly shaped object. It is not a block. It's not something that's perfect. It's not a cylinder. It's not a circle. It's not a cube. I can't do that with it. So for volume purposes, a way around this is to see how much space that object takes up. So what happens in a lab is that we have a graduated cylinder, and this graduated cylinder, normally fill it about half full at least, and just record how much water that you have placed inside of this graduated cylinder. The graduated cylinders, you will often want to use something small enough that is the smallest that you can get by with that will actually hold the object that you want to measure. So halfway fill that up and then record your volume. This is your initial volume right here. It looks like around 600, right? Nothing has to be perfect, especially in an image, but in lab it does. All right. And then I'm going to take this irregularly shaped object, my lump of coal, and then that lump of coal is going to go down into the graduated cylinder. Kerplunk! There it goes. Well, that now takes up space, and it's going to take up space, and it makes my water go up the graduated cylinder, and it rises toward the top. And now if I take a look at the volume reading, it looks like 800 mils instead of 600 mils. This would be my final volume. So what this means is that that object has taken up space, and I can quickly understand how much space it takes up because it just displaced the water by that much space. So if I take the final volume and I subtract the initial volume, I get the volume of the solid object that I am working with. That's a little squiggly S at the very bottom. They will shorthand this. Anytime we do subtraction or anytime we do what they quote change of volume, change of temperature, change of mass, change. Okay, well, I'm going to write a triangle here. So this triangle V is change of volume. So this change of volume is actually represented here in this kind of example equation. And this is our displacement. This is called volume displacement. So that change is represented by delta V. And notice it says cubic centimeters equals a milliliter. So therefore, I now know the density, or I can calculate the density of my solid because I'll take my mass, and my mass here is going to be 482.63 grams divided by, and the volume displacement of this solid object started at 6. It went to 800. Therefore, 200 milliliters is the volume displacement. So on my handy dandy little calculator, I'll pull that up. Look at how fancy this is. I paid so much money for this calculator that will never load. I'm going to take 482.63 divided by 200, and I'm going to get 2.41 as an answer. So 2.41 grams per mil is the value of the density in this example problem. So 2.41 gram per milliliter. Now, teacher, count my answer correct because I just did some math. Okay, so this is, again, volume displacement. It's how we handle the density of an unknown solid object that's irregularly shaped, and this is how we report that value. And notice the units, gram per mil, but more properly, this really should be reported as gram per cubic centimeter because it is a solid object or a solid state of matter. Next up is liquids. Liquids are a little bit more straightforward. It's the same equation, so I'm going to start off with D equals M over V. And to calculate density here, I have taken a amount of a liquid, and I can pour it. And I pour it into a graduated cylinder. And I can measure the volume right there. I'm just going to make up a number for that volume. That volume, let's say, is 425 milliliters. Okay, that's fine. And then that graduated cylinder was probably tared on the analytical balance to make it read 0. And I slowly poured that liquid into that graduated cylinder till I stopped, and I stopped at 425. And then according to the balance, this says I have 997.77 grams of liquid that's in the graduated cylinder that I've just massed, and I have poured out 425 mils of that stuff to get that number. So how do we calculate density here? D equals M over V. Okay, so here in my handy dandy calculator, I'm going to take 997.77 divided by 425. See how hard that was? Oh, it was so difficult. Oh my God. I don't know. I just might as well quit. And then my density here is 2.35. All right, so density equals 2.35. And this is gram per milliliter because my volume was in mils. And this is good because it's a liquid. It's a liquid state of matter. And liquids have density values that are reported in gram per mil. So I'm already there. Looks great. All right, so now let's do an example problem. Oh, gosh, words. Words and math. It's all right. It's not difficult. Suppose a laboratory worker volumetrically pipetted 5 milliliters of a liquid into a tared container. Ding, 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 ding. Oh, 5 mils, that's volume. Right? That's the amount of space. It's volume. The liquid had a mass of 3.2141 gram. Calculate the density of the liquid sample. Okay, wow, this is super hard. Mass over volume. Density equals mass. Well, they give me that in the problem. 3.2141 divided by the volume. Volume's 5 mils. I've volumetrically pipetted it. That is gram per milliliter. So that means on my calculator, I'm going to do the extremely difficult job of keying in these numbers. And these numbers will be, let me kind of position it here. All right, 3.2141 divided by 5. Enter. There's my density value, 0.643. All right, so 0.643 gram per mil. There you go. That's how you calculate density, folks. That's all there is. Do I worry about scientific numbers? No, that's not really what I want you to focus on. Yeah, they are important. Yes, I report them whenever I can. But I don't want to bog you down with all that mess. They do that enough in general chemistry classes. So for us, it's going through the motions, learning how to calculate these things. Okay? If you don't round off to the right value, I'm okay with that. It's not proper, right? But I'm okay with it. It's about getting that number in the first place. That's more important. Example number 2. A person was assigned to measure the density of a liquid. An empty container had a mass of 29.9320. Then the lab technician pipetted 25 mils of liquid into the container. The new mass was 58.0241 gram. Using these values, what is the density of the liquid sample? You have 30 seconds. Yeah, that's probably what's going to happen on a quiz, isn't it? You got 30 seconds to answer 15 questions. Good luck. All right, so yeah, word problem, math, numbers, blah, 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 blah. All right, so density equals mass over volume. We got it. So let's go back and rewind. A person was assigned to measure the density of a liquid. An empty container had a mass of 28.9320. All right, so that mass is probably pretty important. 28.9320 is the mass of the empty container. Then the lab technician pipetted 25 mils. That's volume, right? That's the amount of stuff. All right, so D equals M over V. So V is 25 milliliters. Notice it says, what is the density? So that means that's what I'm solving for. So that D is going to stay as D. So now I need mass. That's my piece that I'm missing. So an empty container started off at 28.9320. And then once I poured that 25 mils in, I took a new mass. And that new mass of a graduated cylinder plus my stuff is 58.0241 gram. So what this means is that I'm going to have to take the difference between these two, right? The 58 value is the cylinder plus my stuff. And the 28 number is just the cylinder on its own. So I need to subtract those two values in order to get the mass of the actual liquid. That was the little trick that was in this problem here. So 58 is not the total mass of the liquid only. 58 is the liquid plus the cylinder. I only need the mass of the liquid. Cylinder has nothing to do with it. So I need to subtract these two values. So 58.0241 cylinder plus liquid minus 28.9320. And then I hit enter. There we go. And the value here is 29.0921. All right, so 29 point, and then if you look at it again, 0921. So 0921 grams. This is the liquid that I've poured out. Before and after, take the difference. So that means, ding, 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 there's my mass. That goes in for M. So 29.0921 grams, and milliliters, 25. And that allows me to calculate the density of this liquid. So if I bring up the calculator, 29.0921 divided by 25 equals, ta-da! My density value is 1.1637. 1637 gram per milliliter. All right. Again, significant figures. I'm reporting inappropriate significant figures. I only need 4 digits in total. I've gave you 5 digits instead. That probably needs to be rounded off to 1.164. I don't really care about that. It's just going through the motions of calculating the density the proper way. That's more important to me right now than reporting the appropriate number rounded off. So notice there was no triangle. Notice there were no multiple equations that I needed for density. It was just straight up, here's the density equation, here's numbers, this is where they go, now let's do a calculation. That's what these problems need to be. All right, example number 3. A density of a solid needs to be obtained. A laboratory supervisor decided to help out in the lab one day. Oh my God, a supervisor decided to help. It is like a brand new day, red letter day, circle it. They obtained a large 100 ml graduate cylinder. She filled the cylinder to the 60 ml mark. She massed 5.3941 grams of a solid and poured that solid into the container. Keep in mind, it doesn't dissolve. And the volume raised to 67.9 mils. What is the density of the solid? All right, so this goes back to this image. She took a graduate cylinder. She filled it to the 60 mil mark. She took a solid. She dunked it down into the graduate cylinder. Volume displacement happened, and it rose. And it went to 67 point something which makes sense. Stuff is there, takes up space. That's how much space it took up. And she was able to get a mass of it. All right. So over here to the side, I'm going to do a side calculation. The side calculation is, beforehand, it was 60 mils. And then I dunked the solid in, and it raised. And it went to 67.9 mils. Well, I take the difference. That is the displacement. 67.9 minus 60 is 7.9 mils. Okay, there's my volume. Ding, 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 ding. Okay, so density equals mass over volume. All right, so density equals what was the mass of the object. It tells you that in the problem. It's right there. So 5.3941 grams divided by, and the amount of space that took up was 7.9 milliliters. Okay, great. There's my calculation. So I'm going to take 5.3941 divided by 7.9, and then I hit enter. Ta-da, ta-da, and my density is going to be 0.683. Again, not appropriate, significant figure-wise. I don't care. So that is the density of that solid object. That gram per milliliter, because it's a solid, is also known as gram per cubic centimeter, and that would be the appropriate unit to assign to that solid material. All right, so those are 3 example problems using density. Again, the density equation, rho for density equals m over v for mass and volume. If you're weak on the algebra part, well, over here is where that triangle could come in handy, but I would tell you, don't even bother with it. Just ignore that you even seen it. I almost regret even putting it into the presentation, just because it confuses people more so than it helps very often. So in the next video, we are going to finally make it to specific gravity. So what is this definition? How is it different than density? Why is it so much more widely used than a density value is? And is there a way that we can do this by hand and make those measurements by hand in a lab environment? And then, once we talk about that, how does it relate to the United States Pharmacopoeia or any of the other pharmacopoeias that are out there, or pharmacopoeias that are out there? Tomato, tomato, you pick it. It's how fancy you want to sound, blah, 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 whatever. All right, so in the next video, we'll pick up here at specific gravity.